Let's take a look at states of matter, what we need to be familiar with for this exam. All right, so it looks like we got 5 questions that we'll try to answer through this video. What is the latent heat of fusion? Um, what is condensation? And so there are a bunch of changes between states of matter. Condensation is certainly one, like freezing, melting, evaporation are some of the others. Sublimation, what is that? Can we describe the process of sublimation? That fourth one is a specific question that we'll get into in a minute. And then what is triple point? And that would relate to like the phase diagrams. So you have triple point, critical point, sublimation, and deposition. So I guess we got 2 questions for the phase diagrams. All right, so we got 3 states of matter. So as we start off here, matter is anything that has mass and takes up space. The 4 most common states of matter are solid, liquid, gas, and there's also plasma. The TEAS primarily focuses on the first 3 and not plasma, so we won't get into plasma today. A solid has the most highly ordered particles of any state of matter because of its strong attraction between particles. While they are in constant motion, these particles vibrate together with little change in their distance between each other. This leads to solids having a fixed shape, fixed volume, and are also not easily compressible. The most highly ordered type of solid is a crystal. Okay. Liquids have a definite volume, do not have a definite shape, and are not easily compressible. So you'll see questions like this where it's like, is it definite or indefinite volume, definite or indefinite shape, and easily or not easily compressible. And then based on that, is it solid, liquid, or gas? So you do have to be familiar with that for these 3. In a liquid, the forces between particles are strong enough to keep them together, and the forces between the particles are weak enough to allow the particles to move around one another freely. This makes liquids change their shape. The distance between particles in a liquid tend to remain pretty constant, and because of this, liquid has a defined volume. With gas particles, they move apart very easily and can fill any available space. Therefore, gases do not have a fixed volume. Gases can be easily compressed or compacted, while solids and liquids cannot. In a liquid, particles are moderately disordered with restricted freedom of motion. In a solid, particles are highly ordered with no freedom of motion. In a gas, particles are highly disordered with great freedom of motion. So that's really everything you need to know about solid, liquid, gas. Again, really we're looking at volume, shape, and compressible. If you know those for each of those 3, you'll be fine on the exam for anything they'll throw at you. Changes between states of matter. Okay. So if something is freezing, that is a change from a liquid to a solid. Probably pretty obvious. I think you could probably guess that. Melting involves a solid changing to a liquid. When liquid water is heated to its boiling point, it turns into a gas, which would be steam. Condensation, which might be a term you're a little less familiar with than these others. Condensation is a change from gas to liquid. I believe we had a condensation question. Yep, exactly what we just said, right? Condensation is a change from a liquid to a gas. Sorry, from a gas to a liquid. And then we also have evaporation, describes the change from liquid to gas, right? And so you could easily get tricked up with condensation and evaporation, making sure that we remember condensation is gas to liquid, evaporation is liquid to gas. Okay, and then we'll jump into latent heat, and there is even a formula here. So these turn into little math problems. The amount of energy needed to melt ice after it has reached the melting point is called the latent heat of fusion. That's a definition you just want to be familiar with, and that does relate to one of our questions, which is it just asks for that exact definition. The amount of energy needed to boil all of the water into steam is called the latent heat of vaporization, right? And so you could easily be see a question and one of the answer choices was latent heat of fusion, one of the answer choices was latent heat of vaporization, and so you want to be familiar with the differences there. Okay, so latent heat is measured in calories. To calculate the amount of heat in calories that is required to complete a phase change in a substance, we use the formula H equals ml, where H is the change in heat calories, m is the mass of the substance in grams, and L is the latent heat of the substance in calories per gram. Okay, so you could see a question like the one we have here. If there is a change of heat of 5,000 calories and the substance has a mass of 100 grams, what is the latent heat of the substance in calories per gram? All right, so they're going to give you two of the three variables, and you just have to solve doing some basic math. So in this question, we are given H and M, and then we need to solve for L, right? With L being the latent heat, right? So you set it up, 5,000 equals 100 L, divide each side by 100, and L, the latent heat, equals 50. Okay, so for phase diagrams, our last part here, there are a few terms to be familiar with for phase diagrams. A phase diagram is just a graph that shows the impact of changes in temperature and pressure on a substance state of matter. So we'll jump into these triple point and critical point and sublimation. All three of these really important and show up a lot on the test. The point at which temperature and pressure reach an equilibrium so that the solid, liquid, and gas of a substance can all exist at the same time is triple point. All right, I think we got a triple point question. It's probably just straight up definition question. What is the triple point, right? The point at which temperature and pressure reach an equilibrium so that solid, liquid, and gas of a substance can all exist at the same time. That's triple point. Critical point, on the other hand, is the point at which the liquid and gas phases of a substance have the same density. That's the critical point, same density. During sublimation, a solid that is at a temperature and pressure below its triple point, which again is the point at which the temperature and pressure reach an equilibrium so that solid, liquid, and gas can all exist at the same time, turns directly into a gas when enough heat energy is applied. Let me say that one more time. During sublimation, a solid that is at a temperature and pressure below its triple point turns directly into a gas when enough heat energy is applied. And that was another question, which I believe was probably just, again, describe the process of sublimation. There you go, right? Really straightforward. And then finally, we have deposition, which is the exact opposite of sublimation. So as we go back and look at our questions, we can see those 5 questions. They've all been addressed, and hopefully you can just hit this pause button, go through them, be able to answer the questions. If you're tripped up on anything still, go back into the video and be able to hear the answer again, then come back, go through the questions, and then you should be good to go.